Hello team, in this video we're going to talk about security in local infrastructures. So here we have a company on the right, so it has many workstations that its employees use, and then it has some networking equipment and it's connected to the internet. One of the main concepts that we have in this scenario is that the company has internal users like its employees and external users which might not have any access at all. So we might want to block all of the external users and allow the internal users to access our internal infrastructure. And here we have underlying assumptions that the external users might have malicious intent or might just be unaware of what the company deals with and what its policies are, so we can't trust the external user even if he or she is not malicious. So one of the main components that the companies use to protect their networks and their resources from external access is to configure a firewall. Anything behind firewall is called the intranet. So these devices, the workstations, the network devices, they are all protected by the firewall. So external accesses towards these devices will be blocked at the firewall unless there is some specific rule in the firewall to allow external access. One common firewall configuration is one that allows outgoing connections from devices like these workstations inside the intranet to go outside. So we can start connections coming from inside to the outside, and then these connections will behave as normal, and we can block all incoming connections. So if someone wants to access a workstation inside the company, then that access will be blocked. So the firewall kind of lets connections go out, but doesn't let connections go in. So this is one possible configuration and a very common one. However, the company can also have some servers that it uses to, serve some content to these workstations, like some network attached storage or some databases that the workstation access, run some applications. But we might also have applications on our servers that might be accessed by the outside world. For example, a public web page. So if we have a public web page like a web store, then we want to let some of these connections reach the servers. So how do we do this? So one common configuration is called configuring a DMZ. So a DMZ stands for demilitarized zone. So it's a zone, that's not militarized. So this is like free for access. And then we have another firewall, and this is the militarized zone. So this is the more well-protected region of the intranet. So then we can configure this outer firewall to let connections in to these devices like the web server and the web front store, and users will be able to access it. So this demilitarized zone accepts connections from the outside world and from the intranet, from this militarized zone. And this second firewall, the inner firewall, has more restrictive security policies that doesn't allow external users to reach the workstations. So these workstations are better protected than the servers because we can't reach them from the outside world. To compensate, the servers are well managed by an IT team, while the workstation users might install applications on them and they might need to run some custom software that's not very well protected. So this is why the inner firewall protects the workstations and the servers are protected by the external firewall and security policies and a trained management team to keep the software up to date and the applications well configured. And a company can also use intrusion detection systems, or IDS. So an IDS monitors traffic on the network. So this is the network IDS over here is monitoring traffic on the network. And it can also monitor processes and files on hosts like the servers and the workstations to look for suspicious traffic or suspicious program behavior. So the IDS allows the company to detect some anomalous behavior in its network, which might be caused by an attack or some software bug, misbehaving application. So these IDSs is an additional form of monitoring what's going on in our intranet to detect these problems. And one last property that we have in traditional infrastructures is that the access control is performed by coarse-grained and more or less static security credentials. So for example, a company might have an admin class of users and the normal employees. So these are only two classes, so it's coarse-grained. And whenever a user is assigned to a class, then he might just stay on that class for a very long time because, employees don't become administrators and vice versa. This is rather uncommon. And here we can see how these credentials can be used to configure access. For example, the workstation might be accessible by the employees and the administrators, while the servers and the firewalls and the intrusion detection systems might only be accessed or configured by the administrators. The employees use the workstation and the administrators can also use the workstations, of course, but they take care of configuring everything else. Unfortunately, this approach to security doesn't adjust very well to a cloud deployment. So we've seen that the cloud has many mechanisms to allow for security, but it does have some incompatibilities with the classical approach to build security that we just discussed. One is that there's no clear network perimeter. We can argue that there's some logical perimeter defined by the virtual network that we have on the cloud, but then this virtual network is ill-defined. We don't know what its borders are. And the isolation between our virtual network and the other virtual networks is delegated to the cloud operator. So we don't actually know what's going on. We have no control over the physical devices, like the servers and the top-of-rack switches and the switches in the leaf-spine topology. We have no control over them, and these devices are shared. So if there's any problem, then we might be subject to what the other cloud tenants are doing. If we want to configure a firewall or an intrusion detection system, then we need to coordinate with the provider because we don't know where the border of our network is. So if we want to configure a firewall at the border, we need to use some firewall service provided by the cloud or somehow coordinate with the cloud so that traffic gets filtered before it enters our virtual network. And because we're coordinating with the cloud provider, if we change our security policies, for example, if we want to change the firewall configuration, we need to tell this somehow, for example, through an interface to the cloud provider so that the cloud provider actually reconfigures its firewall at the border of the data center. And coarse-grained access control may be insufficient in the cloud. There are security challenges specific to the cloud. One of them is lack of control and visibility. So when we rent resources on the cloud, we have limited ability to see what's going on in the infrastructure, the physical infrastructure. And this limits how we can investigate issues. Depending on what we are observing, for example, let's consider that our application is performing below expectations. It might be hard to differentiate between a failure on the underlying infrastructure. For example, maybe the server has a problem on its hard drive. A problem on our application. For example, maybe there's a bug in our application that it's leaking memory and it's somehow performing badly. Or maybe our application is under attack. So differentiating between these three possibilities is hard depending on the visibility that we have. If we can't look at the infrastructure, we can't identify that the problem is with the provider, and if the provider doesn't tell us about the attack, we might also be unable to see it. Ultimately, we might depend on the cloud provider to identify the root cause of the problem and fix it for us. So it might be out of our hands because we don't have access to the infrastructure. Another issue is that the infrastructure is shared. So we've seen that virtualization provides isolation, so our virtual machines should be separate from other tenants' virtual machines. But there's still competition for compute, memory, and network while the virtual machines are running. And although there is virtualization to provide isolation, the risk is increased compared to a classical deployment where we have our own hardware. Because the hardware is shared, so if there's a failure in the isolation, for example, if there's a bug in the virtualization software, then one virtual machine might actually be able to see what's going on with the other virtual machine. And sensitive data might leak, or the resources that were allocated to us might not be available. So if there's a bug in the virtualization, this is a big issue that only happens on the cloud because the resources are shared. And another problem is that everyone is remote in a cloud deployment. So the employees access the resources remotely, the IT staff, same thing, access the resources remotely, and the users and the clients are of course remote like they were before. And the way in which we build cloud native applications also incur some security challenges. One of them is that microservices have many interdependencies. So a microservice can be secured, but because we usually build many of them to provide complex applications, we have many points that can be attacked, and it's hard to secure all of them. Another one, and it is related to identifying what's going on when there's a problem, when there's some anomalous behavior. And it is that the execution environment is very dynamic. So we have orchestration, auto-scaling, rollouts, rollbacks, canaries, and many other technologies that automate tasks for us. And these systems operate in parallel with our application. So when something goes wrong, there are many things that can be going on. And these technologies are confounding factors that we need to factor out when we try to debug a problem. And finally, because we're building applications on the cloud, we might rely on software from the cloud provider. So we may not have control of the software or access to its source code, and we are subject to the security vulnerabilities of this software provided by the cloud.